Welcome and hello, my dear boys and girls. As you can see, today we will start alkenes, next part of hydrocarbon. In this video, it will be a short video. I will teach you some important methods of preparation of alkenes from examination point of view. Upcoming board exams for 11th class. Very important video it will be. So preparation of alkenes. So alkenes second name is olefins. Olefins comes from olephant, means oil forming gas. Oil forming gas. Olefins. That's why they are called olefins. They contain carbon-carbon double bond. So first method of preparation of alkenes is by dehydrohalogenation of alkyl halide. So from alkyl halide we will eliminate HX, HCl, HBr or HI. Okay, this is the reaction. This is CH3, CH2X plus KOH, potassium hydroxide, concentrated. What is the solvent? Ethanol. Remember, we do not use aqueous solvent in this case. Its mechanism we have discussed. KOH in ethanol solvent or methanol. Okay. What happens? This X is removed from this carbon, from alpha carbon, and from beta carbon, H is eliminated. Here we get a carbon-carbon double bond. Carbon-carbon double bond. KX and water. KX and water. So remember, from alpha carbon, X is eliminated, and from beta carbon, H is removed by a strong base. Get my point? So what's X? X is a leaving group. It can be iodine, bromine, chlorine, or OTS. What is OTS? This one. Para-toluene sulfonic acid. Para-toluene sulfonic acid. It is used in elimination reactions. It's a very good leaving group. Okay? So this is the first method of preparation of alkenes. One more additional point is ease of dehydrohalogenation is 3-degree alkyl halide is more reactive towards dehydrohalogenation than 2-degree alkyl halide, and 2-degree alkyl halide is more reactive towards elimination. It is also called beta elimination, and 1-degree alkyl halide is less reactive towards dehydrohalogenation. Then one more point, more substituted alkene is more stable. That's called Saytze's rule. That mechanism we have already discussed. I hope it is clear. This is the first method. Alkyl halide, from alpha carbon, X is removed, and from beta carbon, H is eliminated to form a carbon-carbon double bond here. It is ethene. So this is first method of preparation of alkenes. Okay, X can be any leaving group, halogen or OTS. Okay. Can I rub this? Dehydration. Dehydration of alcohols. What is dehydration? Loss of water. Like this, we have alcohol R, CH2, and OH. It is alcohol, and it in presence of concentrated sulfuric acid, H2SO4, and high temperature 473 Kelvin. It loses water molecule. From alpha carbon, it will lose OH. Okay, we'll get a carbocation. And from beta carbon, it will lose this H. We'll get a carbon-carbon double bond. So the product is RCH. double bond CH2 plus water. So this is alkene. This is alkene. The same mechanism, from alpha carbon OH is removed and from beta carbon H is eliminated in presence of concentrated sulfuric acid. We can also use other dehydrating agents like Al2O3, aluminium oxide. That's also used in this reaction. But let us limit our discussion to sulfuric acid. Okay? So this is second method of preparation of alkenes by dehydration of alcohols. Here also tertiary alcohol is dehydrated fast, then secondary alcohol, and secondary alcohol is dehydrated fast, then primary alcohol. Okay, got it? Okay, fine, very good. Preparation of alkenes is by reduction of alkynes. That is called controlled reduction. Reduction under controlled conditions. There are two types to this. Let us see. You take this one, CH3, C. This is alkyne, but-2-ine. It contains carbon-carbon triple bond. It can be reduced by a reducing agent, lithium or sodium, in liquid ammonia. So this reduction is called Birch, B-I-R-C-H, Birch reduction. And remember, in this reduction we get transalkene. The stereochemistry of reaction is such that the transalkene is formed predominantly. So we get this thing, carbon-carbon double bond, CH3, CH3. It's called transalkene. But-2-ene. So this carbon gets one hydrogen and this carbon gets one hydrogen from reducing agent. Such a reduction we called Birch reduction. B-I-R-C-H. Birch reduction. It is called controlled reduction of alkynes. Okay? So Birch reduction gives trans-2-butene. The stereochemical aspects I will not discuss this time. Can I rub this? Good. One more reduction is, that is, it is second type. Reduction using this one. Catalyst, palladium, in presence of carbon. It is called Lindlar's catalyst. Lindlar's. Lindlar's. Lindlar's catalyst. When such a catalyst is used, we get cis alkene. We do not get trans, we get only cis. You can see like this. CH3, H and H. So Birch reduction gives transalkene, and when we use Lindlar's catalyst, that is hydrogen gas, in presence of palladium and carbon, we get cis alkene. Cis. So methyl groups on same side, hydrogen and hydrogen on same side. So these are three important methods of preparation of alkenes.